Today we're standing in the Niederhafen in Cologne, Germany, before Germany's first LNG bunkering station for inland vessels. I'm standing next to Peter Cole from Pitpoint LNG, and today he will explain in 5 clear steps how the bunkering process evolves and is being finalized for the inland vessel. Peter, can you give a short explanation about step 1, the bunker request?
The bunker request, it doesn't take place here. It takes place in the office where people plan the vessels. So they send an email to our operators to please for a bunker request. Wherein they specify what ship, at what time and date they will expect to arrive here in Cologne, and also how much LNG they wish to bunker. The operator checks if we have the system is ready for their arrival, which includes, for instance, checking how much LNG is in this installation, and then confirms, yes, you are welcome to arrive. After which the operator will move to location at the planned time. That's the first step of the bunker request. This is the technical room. Before the ship arrives, the operator is in this room waiting for the ship. From here he has a perfect view of ships arriving, so he can monitor the progress. Furthermore, he can also see the cameras, what's going on in the terrain, and probably most important, he has access to the HMI, where he can check the status of the installation, but he can also start programming the total amount he wants to bunker, where he sets a pressure and an amount and then accepts. The pumps are ambient temperature because they just sit outside. So before we start pumping the LNG, we need to cool them down. Otherwise, the LNG will turn to gas straight away and we'll be pumping nothing more than gas into the tank. And that takes approximately half an hour, so he can do this before the arrival of the ship.
So then the vessel arrived. Peter, what's next? What will happen next?
Once the vessel has arrived and safely moored the vessel at the quay, the captain will come up to greet our operator. Once they've greeted, the checklist, which is an important step in the process, will be filled out on board of the ship. We cannot show the ship right now because there's no ship, but they will walk to the ship, and there they fill out the checklist. The checklist is important because you discuss the safety measures that are taken, the PPE to be worn, and very important, the language that's spoken. And you also decide upon crucial hand signals during the procedure, like stop, and also who's going to be responsible for which job. On our end we have one operator, so that's very clear, but on the ship there could be multiple people, so you decide on who's going to be responsible for handling the nozzle and making the connection. Non-important questions are best left out of the checklist, but it's still a checklist of 65 questions, and they follow the multiple steps of the procedure. Before you start bunkering, you need to make agreements, and then afterwards you also have a checklist that still needs to be filled out. It's been signed by the captain and the crew, so it's been filled out by everyone.
So after everything is discussed and everyone knows what is expected from them, the actual bunkering can start, I assume.
Yeah. So then the operator moves from the ship to the loading arm, where we can see the next steps of the operations. Yeah. A very important step is cooling the rest of the installation. For now, you've started cooling the pump, and the pump behind you is right temperature. But all the line from the pump to the loading arm is still ambient temperature. So that's the second step of cooling in, is the cooling in the rest of the piping. Once that is done, you have another very important step, and that's checking the ESDs. ESD is a system that checks if certain pressures are correct, and otherwise it will block or stop, put the whole installation in emergency shutdown. To check if the emergency shutdown works, it's a hose with a connector on top. We connect to the ship and then disconnect and see if our emergency shutdown works. And we have the same step for the ship, where we open a valve to see if the pressure drop activates their ESD. And once that's done, the system is cooled down, and communication channels have successfully been established. Then the operations can start. The bunkering arm allows the operator to move the hose to any location on the vessel, or any location, a location without having to drop a heavy hose, what's currently being done with the truck to ship. This is the emergency shutdown. It gets pressure from the ship, and if the connection is broken, then our system will fall in emergency shutdown. So it's a precaution for the safety precaution. Yeah. The operator makes sure that the nozzle is free from this end, and also that the parking brake, which is now currently on, is off. Then the loading arm is ready to move. The loading arm is moved on the pedestal on your left, and also the rest of the HMI controls can be used there.
Well, Peter, I also see a line here that's not without a purpose, I think.
Yeah.
Can you tell something more about that?
When we move the loading arm in position, the nozzle, it's quite heavy, and with the wind can catch it. So first the operator throws down the line to the operators on the ship, so that when it moves down the loading arm, they can gently guide the nozzle to the manifold.
To the right location.
Yeah.
Okay.
Yeah. That's the last thing the operator does before moving to his position. And if everything's cooled in, then and he has his final checks done, they can start moving the loading arm.
And that's when step 5 starts.
Yeah, moving in the loading arm and bunkering. Yeah.
All right. Well, let's see how that goes.
Here you see an HMI similar to the one we've seen upstairs, and it allows you to cool down and do some tests as well on the system. And it allows the operator to have controls over the cooling of the system, and also start moving the loading arm. As you can see, move loading arm, and there's some key checks that the system makes, and that's communicated with the operator to show how the system is performing.
Oh, I am seeing a lot of cryogenic tanks, I guess, Peter. 2 of them. I assume this is the one in which the LNG is being stored.
That's correct.
Can you tell a bit more about the tanks?
The tank holds 200 cubic meters of LNG when it's filled, and to ensure that the temperature and the pressure are the correct temperature and pressures to perform, and to keep it safe, we have liquid nitrogen to the left that cools the system. The liquid nitrogen is approximately minus 190 degrees, and it helps us cool the liquid phase. But there's also a coil in the gas phase that allows to bring the pressure down as well. Once you start bunkering, the valves open and move the LNG through via the pump along the lines down the hose.
Into the hose.
Into the hose in the ship.
It's the 5th step.
The 5th and final step is the finalization, where you come together and finalize your documentation. Currently you're still connected with the loading arm to the ship, and the loading arm is filled with LNG. Disconnecting it at this stage is very impractical, and therefore you wait until all the LNG has warmed up and moved back into our tank, or in the tank of the vessel. In the meantime, you finalize your documentation, and once that is completed, you return back to the loading arm, you disconnect, and you set the loading bar back to its current situation. And then you're ready to receive the next client.
So Peter, what are actually the advantages of shore-to-ship bunkering as compared to truck-to-ship bunkering?
Our setup allows us to bunker faster. We are more flexible with the quantities that our clients are demanding, and we're also safer due to the loading arm and the setup we have here and structured and trained personnel.
So the customer only needs to pay for the quantity he needs.
Yes.
In contrary to a truck-to-ship where they need to take the whole truckload.
Exactly. You're free to decide how much you want per bunkering, and we can provide this because that's.
All right.
That makes
Thank
us
you.
more flexible.
Yeah.